Hello guys, so in this video I'm just going to be talking about how you can make your masters louder and basically just use a simple gain utility and some leveling to pronunciate the loudness in the mix without any gain reduction or really any um, processing. So essentially what I usually do, I mix my tracks individually first, then I gain stage all my faders to 0 bluff, and I set my fader level, and obviously once I do this, I like to make things quite loud, so I'll set the levels at about plus 50, plus 30 luf. Generally I start at 0 luf. I had about I've added 60 decibels here to each channel, and then I bring my master down minus 60, and I just set the level balance in the door using faders and some additional gain utilities if the loudness isn't enough. Once I've set the level balance, I'll route everything into a bus. So I have a drum bus, a vocal bus, and a synth bus. I usually have a latency aux, and then obviously I make things louder here. So when I grouped the buses, the auxes were hitting about 90 to 89 decibels VU for each individual aux. That only told me that my level balance is consistent and what I want, but it also let me know that I've done a good job individually as well. You don't really want your buses level dynamic going past plus or minus 3 to 5 decibels. I think if you do that, you're going to get loudness issues. Something will stick out more than anything else. But if everything's within 2 to 3 decibels of itself between each bus, you're going to have a nice result. So like I said, I was hitting about 89 to 90 decibels VU on each aux, a drum bus, vocal bus and synth bus. And then I went ahead and added another 120 decibels to each aux. Obviously you can see here, and this brought the bus levels to about 200 to 210 decibels per aux. Now the technique here I'm going to be showing you guys, I'm just going to paste I'm going to release these presets on Patreon. The first one is a free gain utility called Bluecat. You can get it on Plugin Boutique for free. It just gives you plus 60 and minus 60. And the second version is the same thing, but I'm going to be using KSHMR chain. So instead of going plus 60, negative 60, sorry, plus 600, minus 600 on each aux, I'm going to be doing plus 600 on one KSHMR, dialing it in parallel and then coming back down to 0, which is essentially going to say this: on these auxes I'm going to be going up 60 dialed in parallel, on the KSHMR version I'm going to be going up 600 dialed in parallel. Now what this is going to be doing is the loudest and quietest part, the door has been programmed to express by the software developer, which in this case is FL Studio. If you look at the noise floor of the mix, it hits minus 60 and then it randomly cuts out to minus infinity, meaning the quietest sound is at minus 60 decibels before it becomes non-audible. The loudest part is about plus 600, plus 650 before it turns to digital fuzz. So if you go in FL Studio and you add about 650 decibels of gain and then you bring it down minus 650 on the master, you're going to find the sound cuts out or turns into digital fuzz. You can't hear it anymore, it kind of glitches out. So what I'm trying to talk here is that in the digital domain, in the DAW, specifically this FL Studio software, you're going to hit a positive and negative boundary that can't be modified. It's a parameter set in stone by FL Studio. Now the way my future self sent back this information to me was that when you dial something loud with this gain utility and dial it in parallel, the binary code, the the waveform's binary information gets split into two states. So if you look here, I've done 90% mixed level, 80, 70, 60, 50, all the way down to 10, 5. Is that, let's say you start with a value of X as your loudness, doesn't matter what it is, and then you add 60 decibels and dial it in parallel. The binary instruction to the software is saying that whatever loudness it was originally, dialed in parallel and added in, and then brought back down to the same exact level, that binary information of plus 60 at 90% added to X is gonna be still in the waveform's information on a program binary level, a script almost. And what this is essentially going to do is it's going to say, even though you brought the sound up and then back down, that plus 60 attribute that you've added to the waveform's parameters is still going to be hidden inside the waveform's program coding. And essentially what I found is, if you look at the gain laws in general for sound, every 10 decibels you add to a sound's loudness makes it 10 times more intense and doubles the previous loudness amount from its original value. So let's say you're at, I don't know, X value loudness, you add 10 decibels of gain, that's going to make it 10 times more intense in terms of pressure and intensity, and it's going to double the loudness. So it becomes X to the power of 2, essentially, which basically means that if you look at the auxes here, you have 600, 600. There will be a percentage of wet dry being taken into account here. But if you just look at it at 600 without the parallel, which you can mathematically do in your spare time, it doesn't matter. You're essentially saying that this aux here, which is positive 600, is going to be making the sound 600 times more intense and 60 times louder. Now when I say 60 times louder, I'm not talking about X times 60, I'm talking about X times 2 to the power of 60. So you're going to be exponentiating the loudness in sets of doubles 60 times from the base value. So at 1 it doubles, 2 it doubles, 3 it doubles, 4 it doubles, 5 it doubles, all the way to 60. And there will be some integer wet dry percentages being applied, but the idea I want to put into your guys' heads is that if you start off with a basic mix and process level, gain stage, sidechain, and you get to the end and you're not happy with the loudness you're getting relative to a reference track, you can add this loudness exploit, almost like a glitch in the matrix that the software developer hasn't looked into specifically, and essentially get a louder mix. And what I found is, if you add a couple of these to your buses, feeding in really hot, and then basically go through the KSHMR aux. Now this KSHMR aux doesn't go up by 60 like this one. What this does is it gets fed in at about 200 decibels VU, and then it dials in parallel 600, comes back down 600, dials in parallel again 600 and down. It basically keeps the sound at 200 with each positive negative implementation. But instead of going up by 60 and dialing it parallel, this new way that I created is essentially saying whatever the sound starting point level is, which is X, you're going to add 600 decibels, dial it in parallel, and then bring it back down. And that 600 decibels in parallel added to X is going to be retained in the waveform. And that loudness will be retained. It won't disappear after you take it out afterwards. The binary structure of the coding is going to say that process that has been applied and taken out with a positive negative knob is still there. And what I also want to talk about is, by doing this, by making it loud and dialing it in parallel in any way, this way or that way, the actual waveform on a spectrometer, if you look at it, there'll be different attributes you can visually see in the spectrometer, such as its fullness, its thickness, its size, and its perceived wave shape. So if it's a square, triangle, or sine, it doesn't matter. This process essentially thickens it up and adds weight, body, and power to it. Not only in intensity, pressure, but also in physical perceived fullness and weight. So you're not only going to get a thicker bass and a thicker premaster, you're also going to be getting a thicker, fuller, louder sound, which exponentiates itself to the degree of the repetitions. So if you look here, we've got 60, 60, 600, 600. If you look at the maths laws that I just basically described, I know from these buses you're going to get about 108 per aux in terms of doubling in loudness, and 1008 times intensity, and I've done 2 for each aux. With this one, you're going to be getting about 120 times the intensity and something loudness, which combines together to give you a thick bass, massive sounds, and a fuller, denser signal. Once I've applied these presets to my buses, I then group them on the pre-bus, add a couple decibels here because it was already peaking at about 200. I've only added 7 decibels to get to about 210, and then I've done the same thing here. Now, if you do this for all your masters, you're going to be adding that information to the waveform on a binary level that says you're making it louder, and the waveform has this parameter of loudness baked into it. It's not going to disappear. I know this from experience. And basically what happens is, once you apply this, either mastering in the same project or rendering out, when you start clipping those peaks with a clipper, which I've kind of done here, I haven't actually mastered this here, I've rendered to a pre-master and done it externally. This actually adds so much more loudness and depth and thickness that if you do the math, you're getting a humongous return in relative to before. So this is basically a technique that I want to talk about and address and highlight for you guys, is that if you go master and you're struggling to match these reference targets inside the law, then you can use this technique and pay some of these presets in to your bus and to your pre-master, so that way when you limit, you compress your master or your pre-master, you can bring out loudness and fullness and weight to a raw digital small shitty sound. And from my experiences, if the quietest part of the mix is -60, which is your noise floor, and you apply this kind of processing to it, which makes it loud and does in parallel, and gives information to the waveform's coding that says this sound has now 2 attributes previous to its original base set, which is adding a loudness parameter or dimension, the noise floor seems to go up. So you're no longer at -60 as your noise floor, you're hitting 0, and at those high luft targets, plus 100, plus 200 luft, you're gonna almost stretch the sound into a new space or field of loudness and noise floor. So that's basically it, guys. I'm just gonna leave these 2 presets in my Patreon, the plus and minus Bluecat fill and the Bluecat mix. All you have to do is basically control the feeding into these presets. So I like to go in at 200 every time. I find if you feed in at 200 and go through this routing, you can add more or less, but it doesn't seem to do anything destructive. It just basically goes, you're going in at 200, adding X minus X in the same amount, adding X minus X in the same amount, and because it's done in parallel, it adds coding in basically loudness programming and binary level to the waveform. And this does the same thing, but in the same slightly more accentuated way. So you're adding huge chunks of level to essentially a pot of what you started off with. And yeah, you can do it on your pre-master, you can do it on your buses, and you can do it on your individual sounds. But I like to do it on the buses and pre-master, because if you look at my RAM, I'm hitting 18,000 megabytes and it's going to get really laggy. And yeah, thanks for watching.